Now with the core basics, or with the getting started section out of the way, let's dive into the core TypeScript syntax, the core features. And that of course means we'll dive into the types, which types TypeScript offers and supports, and how we work with these types, how we assign types, how we can reap the benefits of using types, and all that fun stuff. TypeScript provides many types to JavaScript. Now, JavaScript itself also knows some data types, and I'll come back to that in this module as well, but TypeScript adds many more types. And as you will also learn in this course, TypeScript also enables you to write your own types. Now, let's start with some of the core types which JavaScript already knows and which TypeScript also supports. And we'll also have a look at what the difference between JavaScript knowing the type and TypeScript using that type means. One of the core types we work with in JavaScript and TypeScript is the number type. Now in JavaScript, and the same is true for TypeScript, there is only one number type. There is no special type for integers or floats. Instead, these values here would all be numbers. One would be a number without a decimal place. 5.3 obviously is one with a decimal place. And all these values are of type number. Other programming languages have special integer types and float or double types. JavaScript doesn't have that, and TypeScript doesn't have it either. So we have the number type, which we know from JavaScript, also as a type in TypeScript. We also have the string data type, and that would be text, which you can define in one of these three ways, with single quotes, with double quotes, or also with backticks. The last notation with backticks is a special syntax provided in modern JavaScript and also in TypeScript, which allows us to write so-called template literals that are normal strings where you can dynamically inject some data into them. So strings are simply text, and JavaScript knows about string value types. TypeScript does so as well. Last but not least, one of the core data types JavaScript knows and TypeScript also supports is the Boolean data type. That would be true or false, and that's super important in programming, obviously, especially when working with if statements. Here we got these two values, and that's important because in JavaScript you also might know this idea of truthy and falsy values. For example, that 0, the number 0, is a falsy value. If you use it in an if condition, it is treated as false. The Boolean data type really just knows these two values though, true or false. And that's not just the case for TypeScript, but also for JavaScript. This truthy falsy concept, which you should know, that is not related to data types. That's some behind the scenes work JavaScript does at runtime when it sees certain values in if conditions. So with numbers, strings, and booleans, we got a couple of core data types. Of course, not all. We got objects and so on as well. But let's focus on these types and see what TypeScript does with them, or what we can do with them with the help of TypeScript. For this, I'm back to the project we saw in the first course module. And there I showed you that all you need to do now is run npm start in a terminal, navigate it into this project folder to spin up this live development server, which will reload whenever we change something. And here I opened up this localhost 3000 address in a new tab of my browser. Right now I'm getting an error because I have no app.js file yet. Of course, you find this starting project also attached to this lecture. We'll get such an app.js file, which we're trying to import here in our index.html file, as soon as we compile app.ts from TypeScript to JavaScript. And we can do that in a new tab of the terminal, so that we keep this process running and open a new tab instead, by simply running tsc app.ts. And what this does is it compiles the TypeScript file and spits out a JavaScript file. And once that happens, we can reload this page and we get the time to get started output here. So now we have this setup here where we can write some TypeScript code and then compile it to JavaScript code to see what it does. Now with that, in the TypeScript file, I'll actually get rid of the content there because now I want to dive into these core data types which I just showed you on the slide so that you understand how to work with them in TypeScript. Now let's start very, very simple. Let's say we have a new function, add, and there we expect two numbers and one and add two. and I return n1 plus n2. Just like that. Very simple function, nothing TypeScriptish about it. Now we have two numbers with which we want to work. That could be number 1 here, which is say 5, and also number 2, which is maybe 2.8, whatever you want. Two numbers here. Now obviously, and not very surprisingly, we can add or call the add function and pass in number 1 and number 2 as arguments to this function, store the result in a new constant maybe, and then to see something on the screen, we can console log the result. If we do that, and I recompile this file with tsc_appts, then this page should automatically reload already. If not, you can manually reload, of course, and you should see 7.8. Now, you might think that's not too special, right? This is a pretty straightforward JavaScript snippet, and indeed, there's nothing TypeScriptish about it. Well, let's do something which will break that snippet in normal JavaScript. Let's say this input here is actually not a number, but some text. A 5 in text. And if we now save that and rerun our compilation command here, you'll see that once this page reloads here, I get 52.8 as output. And that's obviously not the correct result of this addition. Now, do you know why we're getting this output in normal JavaScript, which we in the end are executing here? Well, we're getting this output because this is not the result of the mathematical addition, but instead this concatenates this as a string because this input here, 5, is a string. And then JavaScript sees, okay, I got a string, I'm adding something to the string. Well, certainly this something should also be converted to a string so that overall I got a string because the first value was a string. And hence what JavaScript does is it converts 2.8 from a number to a string, concatenates a longer string from 5 and 2.8, hence yielding 52.8 as a string, and returns that. So it's not treating this in a mathematical way, but instead as a string. And with JavaScript, this can happen. Now, of course, you might think, why would I write such code? I'm the developer. Why would I make this mistake? Well, maybe you're not the one making this mistake. Maybe this is getting fetched from some user input, and you introduced a little bug in your code where you forgot to transform this. Or you're working in a team and you're having a couple of script files working together and some other developer introduced such an error. It's not impossible to make such errors, but it can be hard to track them down. Here, of course, it's pretty obvious that something went wrong because we have a basic script, but in a bigger script, you might not even immediately recognize that something went wrong here. And that's where TypeScript can help us. We can add type assignments in this function to our parameters. We can tell TypeScript that these two parameters should be of type number and not be of type I don't care, which is the default. So we do that by adding a colon here after the value to which we want to assign a type. So in this case, after the parameter name, and then the name of the type. For example, number would be one of the supported names. Besides number, you also got string or boolean, but we'll come back to those. For the moment, we need number. And we don't just need it on the first parameter here, but also on the second one. So here also we can add a colon and then number. And now what we're saying to TypeScript is, hey, both parameters here should be of type number. Passing in values of a different type is not allowed. And indeed, my IDE already complains here because Visual Studio Code has built-in TypeScript support. But even if we would overlook this, as soon as I recompile this by rerunning tsc_appts, you'll see we get an error. We get an error that argument of type string 5 is not assignable to parameter of type number. And it even shows us where this happened and gives us the line number, line 8. And it's basically showing us the same the IDE shows here. So in case we overlooked it in the IDE, compiling it now throws an error. And that's the important thing about TypeScript. It only helps us during compilation. It doesn't change JavaScript to work differently at runtime because browsers have no built-in TypeScript support. It can only help us during development before we compile our TypeScript code to JavaScript. But there, it's extremely useful because it adds an extra step, an extra sanity check, where here we find out, oh, we made a mistake. Here, this shouldn't be a string, this should be a number. And we can fix this and we're good. This is what TypeScript does. It helps you during development. It does not change your runtime code. Indeed, here, even with the default settings, it compiled our error here, even though it detected it during compilation, and created a file which causes the incorrect result. Because by default, TypeScript does not step in here. Later, you'll learn how you can make sure that it does. But by default, it doesn't even block compilation. Still, it yells at you and points at this mistake, so that you can fix it and so that you can avoid such mistakes here. By the way, make sure you don't have app.js and app.ts open at the same time. You could get errors here in the IDE regarding duplicate function implementations. Closing the JavaScript file fixes this. So we already see how TypeScript can help us during development. Now, we also know that there is a number type in JavaScript, and we can see it with the built-in typeof operator. This is now not TypeScript specific. This is a built-in operator and keyword supported by JavaScript. We can use it to get the type of a certain value. So here we could console log type of number 1. And what we'll see if we do that is that as soon as we compile this so that we run the updated code, here we print number to the console. Now we do that thanks to this output here and thanks to the typeof operator. And in vanilla JavaScript without TypeScript, we could use that to also improve our function here. We could check if type of number is equal to number, type of n1 I mean, if that is equal to number, and we could also check if type of n2 is equal to number, and only perform our operation here if it is, and otherwise throw an error, or do the opposite and check if it's not equal, or if n2 is not equal, and if either of the two is not a number, then we could throw a new error where we say incorrect input. This actually would be a non-TypeScript way of ensuring that we can't call this function with a string here. If I do this now and I recompile, we get our TypeScript error, but let's ignore that for now. If we rerun this, we get the incorrect input which we're throwing ourselves. So now we hardened this function in JavaScript. It fails at runtime, but failing might here be better than showing an incorrect output, which we had before. So this would be a way of checking the inputs in just JavaScript. You don't need TypeScript for that. That's regular JavaScript code. But of course, this approach has downsides. Sometimes it's the right thing to do. Sometimes you only can validate certain inputs at runtime. But the downside is here, we're checking something which we actually can avoid during development with TypeScript. So yes, we're throwing an error, and in our application, we might have built-in measures that can then fall back to some other behavior to save the running application. But still, we're throwing an error which is really not necessary to occur in the first place. We could have prevented it with TypeScript. And here we really see the difference between JavaScript and TypeScript when it comes to types. JavaScript is dynamically typed, which means it's perfectly fine that we have a variable which initially might hold a number where we later assign a string to it. And that's why we have the typeof operator so that we can check the current type of something at runtime if we have some code that depends on a certain type. TypeScript, on the other hand, is statically typed, which means we define the types of variables and parameters and so on during development. They don't suddenly change during runtime. Now, of course, since TypeScript is compiled to JavaScript, they theoretically could, but if we use TypeScript and we write code where we suddenly assign a new type of data into a variable, where we previously set that this should be a number, for example, and now we're assigning a string, then we get an error during development so that we are forced to be clear regarding the types something can or cannot hold. That's the difference here. So we don't really want to use implementations or solutions like that if we can avoid it with TypeScript. Still, it's important to know that JavaScript, of course, knows about the concept of types. It knows about some types like number, string, and boolean. But using that always means that we can only fail at runtime instead of during development, which is a better place for us as a developer. It allows us to fix bugs earlier. And in addition, JavaScript only knows about a couple of types. As you will learn throughout this course, TypeScript knows about way more types than JavaScript. So this runtime checking is really not as flexible or not as powerful as what we can do with TypeScript. And for all these reasons, this approach is actually not the approach we want to use here. Sometimes it can be useful to get the type at runtime, but sometimes, like in this example, it's way better to get it during development. The only important thing to recognize, of course, just is that with TypeScript, you only get the support during development, not at runtime, because these TypeScript features and checks are not built into the JavaScript engine, so that logic can't execute in the browser. It can only execute during development when you compile your code. So now that we know about TypeScript fundamentals and how it differs and also is related to JavaScript, let's dig a bit deeper into the different core types TypeScript knows. The number is the type we see here, and as I explained, there is no difference between integers, like the 5 here, and floats or doubles, as it would be called in other programming languages, like the 2.8 here. Indeed, in JavaScript, and the same is true in TypeScript, all numbers are floats by default. So for JavaScript, and therefore also for TypeScript, there is no difference between 5 like this and 5 like this. It's the same number, essentially. Now, besides numbers, we also have other core types, and that would be strings, so text, and booleans. So let's also have a look at those. We actually saw all of those in action here in this if statement already, which we learned is a bit redundant. Nonetheless, this here would be a string. Also, of course, 5 with quotes would be a string because it's text. And the result, for example, of this comparison here, that would be a boolean. This operator, the triple equal sign, or the negated equality operator here, that produces true or false. And of course, we can either produce it dynamically in a if check, which we'll often do, or we initialize a variable with a true or false value. So let's do both here. Here we could add a new constant, print result, and set this to true, for example. And just to make it really clear, this could be a variable as well. It doesn't have to be const, it can be a variable, which you would create with let in JavaScript. But since I don't plan on changing it here, I'll go with a constant. And we could pass this as a third parameter here. Let's say we pass in print result, which holds true here. Now, we immediately get an error, of course, because our add function does not support a third argument. We see expected 2 arguments, but got 3. So therefore, we have to make sure we support a third argument. And there we could add a show result parameter. You could name it print result here as well. I'm going with show result to avoid confusion regarding the naming, but technically these two names would not clash. So here I'll name it show result. And I want to make sure that this is of type Boolean by setting this to Boolean. Again, by adding a colon after the parameter here, and then by adding the name of the type. Now this function accepts this, and now what we can do is we can add a if check here and check if show result. If this is true, we can of course compare it to true, but as you know in JavaScript, you can also just pass in the truthy or falsy value here, and JavaScript will evaluate it. And if this yields true somehow, or a truthy value in general, then we'll make it into the if block, otherwise we won't. And let's say we do make it in here, and then I want to console log n1 plus n2. Otherwise, in the else case, if we don't make it in there, then I want to return this. So now this is a function which sometimes returns a value and sometimes does not return a value but output it immediately. Now, you could argue if you want to write such a function which is kind of unpredictable or which might behave unexpectedly if you're passing in true here. But here we're doing it. So this function only sometimes returns, sometimes it also does not return, but instead just logs something to the console. Now here we can actually call add just like this and don't need to store it in result and don't need to console log result, because with print result set to true, add itself, so the function itself will print the result. Hence, if we now save that and we recompile our app.ts file here with the tsc command, once this is done, the page will reload and we still see our output here, but now it's coming from line 6. And if we have a look, line 6 is indeed inside the function. So this is a Boolean. Now let's say we want to customize the output, and therefore we have a result phrase constant here where we say result is colon and then some white space, and we pass that in as well with result phrase here, well, then we could expect this as an argument here as well, phrase, which should be of type string, by adding a colon, and then string is the name of the type. And now we could use that phrase to output it as part of our result output if we're printing the result right in the function. So then here we could have phrase plus n1 plus n2. And if we do that and we recompile by repeating that command, we'll see that this phrase is part of the result. But we also now reintroduce the old bug. Because I have a string which I combine with two numbers, everything is converted to a string here. And that's not what I want. To avoid this, in this function, we could add a result variable here, or a result constant, and store our result here. This will now be treated in a mathematical way because only numbers are involved. And then here we could combine that with phrase or just return it. And now, since this is never directly calculated together with a string, this will always be a number. And yes, then here this number combined with a string will be converted to a string. But since the mathematical calculation finished before that, we'll have the right result. So now if we repeat that and I recompile, we get the right output. So now these are the core data types in action. Let's now make sure we fully understand how types are assigned and also why we don't explicitly assign types down there. So we're using the core types of number, boolean, and string. And here in the list of parameters of this function, we're always explicitly assigning the types with a colon after the parameter name and then the name of the type. So here the names are number, boolean, and string. And in case you were wondering, these are now special identifiers. This overall here is a special syntax which is added by TypeScript. It's not part of the compiled JavaScript code. If we check that code, here these type assignments are gone because JavaScript does not support them. This colon thing after a variable or after a parameter, and then number and boolean and string, these special keywords, this is introduced by TypeScript. The TypeScript compiler understands it. The IDE here supports TypeScript and therefore doesn't complain about these special keywords. JavaScript does not understand this syntax. It doesn't understand a colon after a parameter or a colon after a variable and then the special number or string keyword. JavaScript doesn't understand this, and therefore this is not part of the JavaScript output. It's really just used by the TypeScript compiler, and then, well, it is a compiler because it converts this code to JavaScript code. Side note, you also see it switches const for var, but that's something I'll come back to later. So we have our explicit type assignments here, and it's only understood by TypeScript. Great. Why don't we have them down there? I don't have explicit type assignments here, and by the way, also not here when we calculate the result, for example, because TypeScript has a built-in feature which is called type inference. This means that TypeScript does its best, and it does a pretty good job there, to understand which type you have in a certain variable or a constant. And here, for example, it understands that number 1 will always be of type number in the end because you initialize it with a number. Now, this actually is a constant, so it's even more specific than that, and the type it identifies here is not just any number, it's the number 5. Because you'll not be able to assign a new number or a new value to a const value anyways. If we would change this to a variable, so if you would use let instead, then of course this would not break anything. We can use a variable there. It might not be best practice because this value never changes, but it's also not horrible. But now if we hover over this, we see TypeScript doesn't say, okay, this has to be a 5, but still it detects that the type here is a number. Now we absolutely could write this code here on our own. We can add a colon after the variable name on the left side of the equal sign, and then the name of the type. So basically the same we did in the parameters of this function. But this is redundant, and it actually is also not considered to be a good practice, because TypeScript is able to perfectly infer this type from there. So assigning this is not a good idea. This only changes if you would create this variable in an unassigned way. Like this, if you don't initialize it immediately. Then it's a good practice to tell TypeScript which value will eventually be stored in there, so that when you later assign a value to it, and of course it's a bit redundant here to split this in 2 lines, I'm just doing this for demo purposes, but now if I assign this here, this works because I told TypeScript in advance that this will be of type number. You don't have to do that, it also works if you don't do that, but now you could also add this 5 and you wouldn't get an error, because you're not telling TypeScript anything about the type which will be stored in this variable, and therefore TypeScript allows any type. If you instead add :number here, you're telling TypeScript, hey, eventually a number will be stored in there, and hence if you later store something else in there, like in this case where we store a string, you'll get an error here in the IDE, and of course also if you compile your code. You will get the error we already saw before. So this is how you can assign types. Now, even if TypeScript just inferred a type, and let me fix this, it will yell at you if you break that inferred type. Actually, it's wrong to say even, because of course it does. Why would it not do that? Type inference is there for you to save you code, to avoid that you manually have to assign a type. Of course, TypeScript yells at you if you then use a wrong type, a type that it did not infer. For example here, if result phrase is created with let, so that it's variable, then TypeScript here infers that this will be of type string, because we initialize it with a string. So this is basically the equivalent to not initializing it and setting the type on our own, and then assigning a value later. Now if we change result phrase to, let's say, 0 here, for whatever reason we might want to do that, well then we get an error here, that type 0 is not assignable of type string. And that makes sense, right? TypeScript inferred that we want to store a string, we're now trying to store a number, we get an error. That's the job, the core task of TypeScript, checking types and yelling at us if we're using them incorrectly. Let's dig deeper into the core types TypeScript supports. The next type that's interesting is the object type. Now, you know objects in JavaScript, they look like this. You have curly braces and then you have key value pairs in there, and such values would also be treated as object types in TypeScript, so any JavaScript object is of type object, though I will already say there are more specific versions of objects in TypeScript, so that you can say this is not just any object, this is an object which has to have these properties, or which has to be based on this or that constructor function. But we'll get there step by step. To dive into objects, I'll first of all rename app.ts here, and I'll rename this to basics.ts here, and add a new app.ts file, which will then overwrite the old app.js file once we compile it, where we can now dive into objects. And let's start by creating a basic object here, let's say a person with the curly braces here, and we give this a name. Here I'll go with Maximilian because that is my name, and the age of 30. Now, of course, we can console log person here, and if we do so, and we compile this, unsurprisingly, we should see that object being printed here in the console. Now, what we also can do in JavaScript is we can try to access, let's say, nickname, a property which does not exist here. Now, you immediately see that TypeScript is not too happy about that, and hence my IDE tells me. It tells me that property nickname does not exist on that type. So if we save that, and I try to compile that, we indeed get that same error down there. The TypeScript compiler does not like this, and it tells me that we have no nickname property on this object. It finds out that we don't have this nickname property because if we hover over person, it inferred, we can see there is a colon after person, so after the variable or constant name, it inferred that this is the type of data which is stored in there. Now that's not just object, as you can tell, that is a concrete object. It's an object with a name key, where then the type in turn has to be a string, and the age key, where the type has to be number. And actually this can be confusing here. This here obviously looks like a JavaScript object, curly braces, key value pairs. Well, the first important thing to see here is that we have a semicolon here after each line. We don't have that in a JavaScript object, we have a comma here. And indeed, this is not a JavaScript object here, which is created somewhere. This is the object type inferred by TypeScript. And object types are written almost like objects, but of course we don't have key value pairs there, but key type pairs. Object types are there to describe, well, the type of object that is getting used somewhere. We could be more generic. I could explicitly assign a type here to the constant of object. Object is one of the built-in types, just like number and string. And now if I hover over this, we see persons of type object. And now TypeScript really only cares about the fact that this is our object type. Now still, if we compile this, we get that error though, because TypeScript still analyzes our code and sees that we try to access something which doesn't exist there. But it's important to understand that it all starts with this most generic object type. But often you want to be more specific than that. You don't just want to work with that generic object type. You really want to get the full support. For example, right now if I add a dot here and I have a look at my auto-completion, I get no help there at all by my IDE. Reason for that is that all we tell the IDE is that we have a value here in person, which is of type object. Indeed, now we actually also get an error if I try to access name. Name exists here, right? But what we tell TypeScript here is that we just have an object where we don't give any other information to TypeScript. So actually TypeScript doesn't support any type of property because we don't tell it anything about the object. So we should be more specific. And we are more specific by setting a specific object type, the thing which TypeScript also inferred automatically. We do this by adding curly braces here after the colon, after our const or variable name. So this here does not create a new JavaScript object. This will actually be stripped out of the compiled JavaScript code. Instead, this is just TypeScript's notation of a specialized object type, so to say. So of an object type where we provide some information about the structure of the object. Now, by assigning just an empty pair of curly braces as a type, we essentially do the same as with object. We tell TypeScript that this is some object. Now we can be more specific though. We can add key value entries here, however, not key value, but key type instead. So here we could say the object which should be stored in person should have a name property, and the value of that name property should be of type string. So here we describe the type of value which will eventually be stored in name. Now, by the way, you see I'm getting an error here, because what I'm telling TypeScript now is that my person should have an object with exactly one key value pair where the key is name and the value of that key is string. But we then assign an object with two key value pairs. Name, which holds a string, that is fine, but age, which holds a number, and that would not be fine. So here we have to adjust this by adding a semicolon and then adding another key value pair here where we say age should be of type number. So not 30 here. That actually would be supported in TypeScript, that we restrict it to one specific number, but then we'll run into issues as soon as we change that. Instead, here I just want to say age should be some number. And now we basically are explicitly assigning the same TypeScript inferred before. As you learned, that's not a good practice, but to understand object types, I wanted to do it here. Still, this is something you can do. It's better to let TypeScript infer this as we did before, like this. Now, just to show something interesting, if I switch back to the suboptimal code, where we explicitly assign a type TypeScript would be able to infer, if we compile this code, of course, it works, we can access the name property, but if we then have a look at app.js, we see this type assignment is removed here. And that, of course, should be something expected. As I mentioned, types and type assignments are not part of JavaScript. They're TypeScript only. I just wanted to show this again to make it really clear that this syntax here is not creating some JavaScript object which is somewhere in our code. This is just TypeScript's representation of an object type that helps TypeScript understand the objects you're working with. The better syntax, of course, is this syntax, as you learned. Now, besides objects, we also have arrays in JavaScript, very important type of data. Arrays are created like this in JavaScript, as you know, and you can store any data in there. Numbers, strings, booleans, objects, other arrays. You can have nested arrays after all. And you can also mix data. You can have an array with strings and numbers mixed. And TypeScript also supports arrays. Any JavaScript array is supported, and the types of that array can be flexible or strict. Now let's have a look at that in TypeScript. For that here in app.ts, let's say our person also has a hobbies key. But of course, we could also have a variable or a constant hobbies outside of the object. So using arrays is exactly the same inside of objects and outside of them. So here we have hobbies, and hobbies could be sports and cooking, let's say. So I have two elements in there, and these elements, as you can tell, are strings. Now, if we hover over hobbies, TypeScript correctly detected that this is of type string array. Now, that's a syntax you haven't seen before, but this is how TypeScript describes an array of data. You have the square brackets, and in front of that, the type of data which is stored in there. Now, this is the type TypeScript inferred. It saw that here we have an array and that we only have strings in there, so it inferred that hobbies probably should be an array of strings. And indeed, for hobbies, that makes a lot of sense. Of course, you can also explicitly set the type of a variable. If we would add a new variable, favorite activities, and initially that should be empty, then we might wanna explicitly set the type of data stored in there. And now let's say that should be an array of strings. Well, then we can just repeat what we just saw. Type string, and then square brackets thereafter. And this tells TypeScript what we store in here is not just a single string, it's an array of strings. And indeed, if I try to store just sports in there, I get an error. I get an error because that here is a single string and not an array of strings. I don't get an error, of course, if I wrap this into square brackets, and therefore effectively I create an array. I again do get an error though if I add a number, let's say, because we defined this to be an array of strings. Now here we have a mixed array. It's an array of strings and numbers. So that does not work and is not supported here. If we would want to support such a mixed array, one solution would be to use any here. The any type is a special type in TypeScript, which we'll have a closer look later, which basically means do whatever you want. It's of course a type you don't want to use too often because you'll lose the benefits TypeScript gives you. You're back in JavaScript world, where you also can use any value anywhere. So any is really flexible, but the flexibility comes at the price of basically giving up all benefits TypeScript offers. So here I want to go back to string because I really don't want to have a number in there, and hence we can remove the number and we're good. Arrays also give us a great example, actually just like objects and their properties, how dynamic TypeScript's type inference is. If we add a for loop here at the bottom, and we want to go through all the hobbies of person, we can of course use a traditional for loop with for const hobby of person.hobbies, so accessing the hobbies property and going through all the hobbies there, storing each hobby for each iteration in this constant, and then we can console log hobby here. Now that's not too fancy, that's something we know from JavaScript, right? If I now compile this app.ts file down there, we get the name from this line and thereafter the two hobbies being printed. But what's actually interesting here is that on hobby, we can access anything we can access on any string. For example, to uppercase. I get this auto-completion and TypeScript does not complain. Why does it not complain? Because it knows that hobbies is of type string array. So when I access person.hobbies, TypeScript's inference detects that hobbies will be an array of strings. So hobby, on the other hand, is correctly identified as being a string, because since we go through an array of strings, well, the individual values have to be just strings. And therefore TypeScript offers us great support down there and allows us to do anything with hobby that can be done with a string, because it knows with certainty that hobby will be a string because of the types we set up there. And that's really flexible and of course a great feature which makes writing code a lot easier and way more flexible and secure. For example, we would get an error here if I would try to access hobby .map if I thought this would be an array. The map method is available on arrays, but not on strings. And here correctly I get an error that map does not exist on type string because it doesn't. So here we get an error, and that's good that we get it, because this would be wrong. And here we see TypeScript's inference really shine. So arrays are supported, and with numbers, strings, booleans, objects, and arrays, we got the core values or value types JavaScript knows supported in TypeScript. As you will learn at the example of objects and arrays, TypeScript even offers way more functionalities there, but that's a bit more advanced, which is why we'll have a look at that later. But even these core types, with what you'll learn in the previous lectures, are supported. Now, TypeScript also adds a couple of new concepts, new types, which we don't know from vanilla JavaScript. For example, the tuple type. Now, you might know tuples from other programming languages. JavaScript does not have them. This is a tuple, for example, and you would say, well, this is an array. It is an array, but it's a fixed length array, and actually not just fixed length, but also fixed type. Now, where could this be handy? Let's say here on our person, we actually have another property, role, which is an array with exactly two elements, where the first one is, let's say, a numeric identifier, like 2, and the second one is a string identifier and a human readable description, like author. Now, this should always have exactly two elements, because a user or a person in this application, which we're writing, let's say, can only have one role, and a role is only made up of two elements. Of course, we could have used an object here, but for some reason we want to have an array with exactly two elements, where the first element always is the numeric identifier, and the second element always is the string identifier, or description, or however you want to call it. Now, if we hover over this, TypeScript actually infers this strange type, which we haven't seen before. Effectively, this means TypeScript understands that we have an array which might hold either strings or numbers. This is a union type, and we'll dive into those later. The key takeaway is that TypeScript understands that this should be an array with these types of values. The downside is that we could run this code though. Person role push admin. Now, for our application, this might not make sense because we know we only need two elements. Still, TypeScript doesn't know that we only want two elements. We would also be able to switch person role, the second element with index 1, to be a number as well. This would work because TypeScript only knows that role should be of type string or number array, and therefore assigning a number here to the second element and therefore replacing it with a number would be allowed, because we're just saying something about the types we generally can use in there. We know we want to have exactly that structure. Two elements, first element number, second element string, but TypeScript doesn't know that. Well, for such a scenario, a tuple would be perfect. We can tell TypeScript what role should be by explicitly setting the type of role. So here we also have an example where TypeScript does infer a type, but we explicitly want to override it. Now here we can therefore add an explicit object type by adding a colon after person, then the curly braces, and then name should be a string, age should be a number, and hobbies should be a string array. So all as inferred by TypeScript. So for that, we wouldn't have required this explicit assignment, and as you learned, it would have been bad. But now we have a scenario where the inference does not work in the way we want. And we want to set role to be a tuple. Now, instead of setting it to string array or number array, or using the same type that was inferred here earlier, we can now use a special type. We use square brackets again, but now inside of the square brackets, we add number, and then a comma, and then string. Now, this marks a tuple type here. A tuple is a special construct TypeScript understands. In JavaScript, it will be a normal array, but during development with TypeScript, we'll get errors with code like this here. Now, what do tuples do? This here tells TypeScript, I want to have a special array with exactly two elements, because I have exactly two types in there, and the first element should be a number, the second element should be a string. Hence, if we compile this code here, I get an error regarding 10 not being assignable as a type here, because we want to have a string as a second value. And if I then assign 10 as a second value here, then I obviously don't follow this rule. Now, if we comment this out and we compile, this works. That's a bit strange, because why does pushing work here? Because we're also saying that role should have exactly 2 elements. So why can we push admin onto the role array here? Push actually is an exception, which is allowed in tuples. So unfortunately, TypeScript can't catch this error, but at least it ensures that we're not assigning a wrong value here. And outside of push, we also get some support regarding the length. If we set person.role to a new value, for example, an empty array is not allowed. One with exactly the structure we defined up there is allowed. If I added an extra element here, then we would again get an error. So the length is enforced if we assign it like this, but not for pushing and so on. This is something you have to be aware of. But still, getting this support and this support is pretty nice. And if you have a scenario where you need exactly X amount of values in an array and you know the type of each value in advance, then you might want to consider a tuple instead of an array to get even more strictness into your app, to be even clearer about the type of data you're working with and the type of data you're expecting.